Next we are going to see motion of connected bodies. When objects are connected by a strings of force F is applied either vertically or horizontal or along an inclined plane. It produces tension T in the string, which affects the acceleration to an extent. First we discuss about the vertical motion. Consider two blocks of masses M1, this one M1 and M2, connected by a light and inextensible string that passes over a pulley. Let the tension in the string be T. So this T is act upward direction and the gravitational force act downward direction. Note this point, M1 is greater than M2. So M1 is downward and M2 move upward. When the system is released and acceleration is T is 10, the system is released, both the blocks start moving upward and downward direction vertically. Then with the same acceleration, the gravitational force M1G act on mass M1 and M2G act on mass M2. Okay, the lifting mass, M1 is used in lifting mass M2. Okay, so draw the free body diagram for M1 mass. So that is upward force tension act upward direction and gravitational force act downward direction M1G. Then the XY direction you already know. In this case mass M1 have no X direction and M2 is also no X particle move, the object move no X direction. Okay, so in M2 the tension acts upwards and gravitational force downward direction, that is M2G. According to Newton's second law, for mass 2 F equal to ma. Okay, that is M2a. So this is equal to T j cap minus M2G j cap equal to M2A j cap. Okay, then you write this equation. What is that? F equal to, according to Newton's second law, you write this one, F equal to M2A and F equal to, F vector equal to T j cap minus M2G j cap. Okay, these two equations are equal. So you write T j cap, it is vector symbol, you write j cap. Okay, these two are equal. So T j cap minus M2G j cap equal to M2A j cap. J are cancel with each other and then you write, and then the acceleration in y direction. Okay, so you get T is equal to minus M2G equal to M2A. And similarly the second law is applied in mass M1. So that is also, what is that? Yeah, T mj cap minus M1G j cap equal to minus M1A j cap. Okay, because as mass M1 moves downward, so okay, downward direction is minus y direction, so you write minus. Upward direction is positive y direction, so you write put a sign positive. Okay, then j or both sides are j or cancel, so j cap are cancel, so t minus m1g equal to minus m1j. Rewrite this equation, so you get m1g minus t equal to m1a. So in this case m1g minus m2g equal to m1a plus m2a, because adding these two equation, which two equation, this one t minus m2g equal to m2a, this one, and t minus m1g minus m1a. Okay, these two equation you adding, so you get m1g minus m2g equal to m1a plus m2a. m1 minus m2 into g equal to m1 plus m2 into a. Okay, so you write a equal to m1 minus m2 divided by m1 plus m2 into g. Okay, the masses are equal, m1 equal to m2, so m1 minus, this one is a minus sign, so m1 minus m1 divided by m1 plus m1 into j. So numerator becomes 0, so a becomes 0, acceleration becomes 0. So if the masses are equal, there is no acceleration and the system as a whole will be at rest. To find tension acting on the string, so substitute the value of acceleration in the equation t minus m2g equal to m2a. So t minus m2g equal to m2 into m1 minus m2 divided by m1 plus m2. So t in this m2g is right side, so t equal to m2g plus m2 into m1 minus m2 divided by m1 plus m2 into g. So you take a LCM, so m2g is a common, so take outside in this equation, so t into m2g into 1 plus m1 minus m2 divided by m1 plus m2. Take LCM, so you get m1 plus m2 plus m1 minus m2 divided by m1 plus m2. Okay, m2 cancel, so you get 2m1 divided by m1 plus m2 into m2 into g, that is equal to t. Okay, this is only magnitude of acceleration. Which one is magnitude of acceleration? A equal to m1 minus m2 divided by m1 plus m2 into g is a acceleration, magnitude of acceleration. For mass m1, the acceleration vector is a vector equal to minus m1 minus m2 divided by m1 plus m2 into j cap. Okay, mass m2 in vector notation, it is upward direction, it move upward direction, acceleration is acting upward direction, so a vector equal to plus m1 minus m2 divided by m1 plus m2 into j cap. Okay, do you understand this one? Then next case is horizontal motion. In this case, mass m2 is kept horizontal tape and mass m1 is hanging through a small pulley. Okay, so in this there is no friction on the surface. Okay, so first draw the free body diagram. Okay, so in the case m2 point mass m2, three force acting on the body, the normal force acting upward and gravitational force acting downwards and tension act x plus x direction. In the case of m1, two forces acting, that is acting on the mass m1, that is upward force, that is tension force act upward direction and gravitational force m1g act downward directions. Okay, So according to the Newton's second law, F equal to ma. This ma is equal to T j cap minus m1 g j cap, that is equal to minus m1a j cap, because it acts along y direction. Then j caps are cancelled, so you get T minus m1g equal to minus m1a. Then applying Newton's law, applying for m2, mass m2, T I cap equal to m2 a I cap. I cap cancel, so T equal to m2 a. Then there is no acceleration along y direction for m2. So n j cap minus m2 g j cap equal to 0. So j are cancel. So n minus m2g equal to 0. So you get n equal to m2g. Substituting this value, T equal to m2a is substitute in equation. Which equation? T equal T1 minus m1g equal to minus m1a. Okay, so substitute the equation, so you get m1a minus m1g equal to minus m1a. So both sides m1s are a values are kept one side, so m2a plus m1a equal to m1g. So take it a left side in a is take it outside, so m2 plus m1 equal to m1g. So a equal to m1 divided by m1 plus m2 into g. So T is equal tension in the string can be obtained by these equations. That is, substitute a value in T equal to m2a, this equation. Okay, T is equal to m2a. In this equation you substitute the acceleration value. So T is equal to m1 m2 divided by m1 plus m2 into g. So comparing motion in both cases, that means vertical cases and horizontal. Vertical cases tension is T is equal to 2 m1 m2 divided by m1 plus m2 into g. In horizontal, the string horizontal motion is half of the tension for vertical motion for same set of masses and strings. This result has an important applications in industries. That is, the ropes used in conveyor belts, that is horizontal motion. You know the in Malamula Dam, the rope cars are working. That is, these principles are used in that case. In Palani also, you know that ropes are used these applications. Okay, then for longer duration than those of cranes and lifts, vertical motions are used.